Okay, so in this lesson, we're going to be graphing lines. So let's start with the first one. So let's graph y equals negative 2x plus 1. The first way we're going to do it is we're going to use a t-table to plot some points, and then I'm going to make a connection between that and the slope and the y-intercept, and that's the way that um, your, your textbook wants you to graph these lines. So let's first of all graph this using a t-table, then let's make the connection to slope and intercept. So if I use a t-table, and remember to graph a line, this is a line, because the y and x are both being raised to the first power, so this is a linear function. Um, so if x is 0, I'm going to get y equals negative 2 times 0 plus 1, which is 1. If x is, let's say, 2, I'm going to get y equals negative 2 times 2 plus 1, which is negative 4 plus 1, which is negative 3. And just use one more point to make sure that they all line the same, that these points line the same line, because I could have made a mistake somewhere in the computation. So if all I do is graph 2 points and one of them is incorrect, I'm going to be graphing the wrong line. So use one more point just to verify that those 3 points are collinear, that they lie on the same line. So if x is, let's say, negative 1, I get y equals negative 2 times negative 1 plus 1. So that's negative 1 times negative 2 is 2 plus 1, which is 3. And so now I'm going to plot those points rather, and let's see what we get when we plot those points. So let's see. So 0, 1 is here, and 0, 1. 2, negative 3 is here, and then negative 1, 3 is here. And so if I use a straight edge to graph this, I'm going to get those 3 points are collinear, so it seems okay. But this is what the graph looks like. Looks like this. Okay? And so there's the graph. And so notice that the graph is falling, so the slope should be negative. Okay? Now, here's what I want to do. So you graph this line, so that's number 1. You graphed it. Y equals negative 2x plus 1. But I want you to notice that we graphed it using a t-table. Using a t-table. In this section, in this lesson, we want you to be able to graph this using slope-intercept. So let's make the connection between this line and the equation. So let's find the slope of this line. All right, using the 2 points. I know 2 points on that line. I know 2 points are 0, 1, and 2, negative 3. Let's just use those 2 points. All right, so remember, 2 points on the line are these. So let's find the slope, x1, y1, x2, y2. And so if I use a slope formula, y2 subtract y1 over x2 subtract x1, I get negative 4 over 2, which is negative 2. So my slope happens to be negative 2. Now I want you to go back to your equation. Do you see negative 2 anywhere in that equation, this negative 2? Yeah, you see it here. So this number you multiply an x by, that happens to be the slope. This is your slope right here, negative 2. The coefficient of x is your slope. Now, the question becomes, what does this 1 represent? What does that 1 right here represent, that constant 1? Well, look at your graph. Look at this right here. You see this right here? That 1? See right here? That's where the graph crosses the y-axis. So that constant is your y-intercept. Okay, so that's your y-intercept. So here's the idea. There's something called slope-intercept form. Slope-intercept form. All right, slope-intercept form. And so slope-intercept form looks like this. Y equals mx plus b. And so notice that this equation was in that form. Y equals mx plus b. All right, where m is the slope and b is the y-intercept. That's where the graph crosses the y-axis. The graph crosses the y-axis. Okay? All right, so that's where the graph crosses the y-axis. Now, what we're going to want to do now is use the slope and the y-intercept to graph a line. All right, so before we do that, let's kind of review something. Let's graph a line that has slope negative 3/2 and y-intercept of 4. So negative 3/2 and a y-intercept of 4. Okay? So let's graph a line that has this information. So slope is negative 3/2 and the y-intercept is 4. Now remember, to graph a line, you need 2 points. You need 2 points to graph a line. Right. I know one of those points already. One of the points I know is this y-intercept. That's one of the points. So I'm going to go ahead so let's call this number 2. Number 2. So I'm going to go ahead and label this number 2 right here. So I'm going to label the point. So the first thing you're going to do is label the point that you know of. So I know that a point on that line is the y-intercept 4, so that the graph will cross the y-axis at 4. So I know this right here. Okay, that's one of the points. From that point, nowhere else, but from that point, you're going to use a slope. Now remember, slope is rise over run. So rise meaning you go up and down, run meaning you go left and right. Okay, so in this particular case, my rise is numerator and my run is the denominator. But in this particular case, my numerator is negative and my denominator is positive. Okay, so as we go through this, we're going to be discussing what's negative, what's positive. So my rise is negative. All right, so from this point, not the origin, nowhere else, but from that point that you know that's on the graph. So you know that your y-intercept is this. From that point, my rise, remember, you go up and down. My rise is negative, so that means from that point I'm going to go down since it's negative. So since it's negative 3, I'm going to go down 3 units. 1, 2, 3. Now don't put a dot there, you're just staying there for the moment. Again, don't put the dot and say that's your point and draw this vertical line, okay? You go 1, 2, 3, and then you stay there for a moment. Don't put a dot. Then you look at the run. My run's a positive 2. Since my run's a positive 2, you're going to go to the right 2 units. So 1, 2, 3, down 3, to the right 2, and now you put your dot. You label your point, or you put the point there. So this is the point 2, comma 1, and this is the point 0, 4. All right, so let's talk about this again. So this can be important in a little while. So the slope is negative, so that's your rise, and your rise is negative 3, and your run's positive 2. So from your point that you know of, from this point of 4, your y-intercept is 4, you go down 3, 1, 2, 3, because your rise is negative, and since my run is positive, I go to the right 2, 1, 2, label your point, and then you draw your line. And so there's the graph. Okay, there's your graph. So that's how you graph using slope and y-intercept. So you're going to graph using slope and y-intercept. Okay? All right, let's look at number 3. All right, number 3. Suppose you had this. All right, suppose you had y equals negative 2/5 x plus 2. Y equals 2/5 x plus 2. Now remember, they want you to use slope and y-intercept in these directions. It's going to say slope and y-intercept, so you must graph using slope and y-intercept. All right, so the slope, first of all, notice that it is in y-intercept form. This is in y-intercept form. Y equals mx plus b. Y is by itself, so that's slope and intercept form. So m is negative 2/5. Now, it did not matter, listen to this, it did not matter whether you said negative 2 divided by 5 or if you said 2 divided by negative 5. It doesn't matter with regards to graphing it. You're going to get the same graph. But in terms of slope, we normally put the negative in the numerator, just to let you know. All right, so this is a preferable way of writing it, so this is preferred. All right, but it does not matter. I'm going to show you that when we go over this, when we graph it, that using this or using this, you'll get the same line. All right, so the slope is negative 2 fifths. The y-intercept is 2. Remember, that's the y-intercept. Not the x-intercept, but the y-intercept. All right, so let's graph this. So, all right, this is number 3. So remember, the first thing you do is you plot the y-intercept. All right, you plot the y-intercept. So my y-intercept is 2, positive 2. So here's positive 2 right here. That's where the graph crosses the y-axis. From that point, I'm going to use the slope, rise over run. So let's use this one first. From this point, from the y-intercept. So the rise is negative 2, so that means from here I'm going to go down 2. 1, 2. Again, don't put the dot there. You're just placing it there for a moment. And then my run is a positive 5, so I'm going to go to the right 5. 1, 2, 3, 4, 5. Okay, so I get that point. Now, and then I would draw a straight line through them. Now, I want you to notice something, okay? Suppose you use the other one. So starting from the y-intercept, remember, always start from the y-intercept. My rise is positive 2. Since it's positive 2, I'm going to go up 2. 1, 2. See how I did this? 1, 2 this time is positive. My run is negative. If your run's negative, you go to the left. If your run's positive, you go to the right. That's how we got this one right here. So it's negative this time. So we're going to go up 2, 1, 2, and then to the left 5. 1, 2, 3, 4, 5. And I want you to show you that it did not matter which one you used, whether you use this one or this one, because those points, all 3 points, lie on the same line. So it did not matter. Okay? Now, if it's set to label the points, here's what it means to label the points. 0, 2, list the coordinates. Negative 5, 5. Oops, sorry, that's, let's see, 1, 2, make sure we went up 2, so that's negative 2, 4 rather. Negative 2, 4, and this is 5, 0. All right, so again, did not matter which one you use, but that's how you did. That's all you did. All right, let's look at another one. So this is number 3. Let's do this one. Suppose we had this. F of x equal 2/3 x minus 3. 2/3 x minus 3. F of x equals 2/3 x minus 3. All right, well, notice that f of x, remember f of x, this is function notation. They're all functions because remember they all pass the vertical line test. So they're all functions that we're doing right now. These are all functions. All 4, even this one, are functions. But remember, f of x means the same thing as y. Just keep that in mind. Okay, so this is the same thing as saying y equals 2/3 x minus 3. So notice this is in slope-intercept form. This is slope-intercept form. You got y by itself. Okay, so y equals mx plus b. So that's slope-intercept form. Now be careful when you tell me the y-intercept. First of all, the slope is the coefficient of x, 2/3. Now don't say the coefficient, the slope is 2/3 x. Remember, the slope is just that number in front of x. So don't say 2/3 x. It's incorrect. It's wrong. So the slope is just the number, the coefficient of x. It's just that number. So it's 2/3. Now be careful with the y-intercept. The y-intercept is not 3. The y-intercept is a negative 3. You got to keep that sign with it. Just like when you did this, the slope, you didn't say the slope was 2/5. You said the slope was negative 2/5. It's that number you're multiplying the variable by. The y-intercept is that constant. So my constant here is a negative 3. Okay? All right, now let's graph number 4. So number 4. So remember, the first thing you do, if you now know the slope and the y-intercept, remember the first thing you got to plot is the y-intercept. So that's where your graph crosses the y-axis. So my graph crosses the y-axis at negative 3. So here's negative 3 right here on the y-axis. So that's where the graph crosses the y-axis. From here, I'm going to use the slope. The slope is positive 2/3. Rise over run. So my rise is a positive 2, my run's a positive 3. So from this y-intercept, I'm going to go up 2, because my rise is 2, and then my run's 3, so I'm going to go to the right 3. 1, 2, 3. All right, now remember your slope is positive, so your line better be rising, and it is. All right, and then you just draw a line through those 2 points. and you're done. That's all you do. Now, if you asked to label, label means this. The coordinates of this point here is 3, comma, -1, and the coordinates of the y-intercept is 0, -3. Okay? All right, so that's all you do. Rise, so y-intercept, slope-intercept form, y equals mx plus b. All right, and then let's look at this one. Suppose you had number 5. Suppose you had f of x equal negative 1/4 x. Suppose that's all you had. Okay. Y equals, remember f of x, same thing as y. So this is in slope-intercept form, mx plus b. It really is. Although you don't see the constant, if there's no constant there, what's it is understood to be? Well, it's understood to be 0. Y equals negative 1/4 x plus 0. Okay? So that's your b right here. So the slope is, now remember, it's the coefficient of x, so the slope is negative 1/4. And your y-intercept is that constant. Remember, you don't see it, but it's understood to be 0. All right, and then you graph that line. First thing you got to do is plot your y-intercept. Now, the y-intercept of 0 makes you understand where that's located. See, this is y-intercept 1, y-intercept 2, y-intercept 3, and so on. This is -2, -3. 0's here. That's the origin. So that's where the y-intercept of 0 is. That's the origin. That's where y is 0. So from that point, from the y-intercept, I'm going to use slope rise over run, the slope, which is negative 1/4. And again, it did not matter. It did not matter whether you said negative 1/4 or 1/-4. Remember, you still get the same line. You would get a different point, but it would all lie in the same line. All right, so we said the slope is negative 1/4. So from this point, my rise is -1. So I'm going to go down 1. And my run rather, is a positive 4. So I'm going to go to the right 4. So again, negative 1/4. So my rise is -1. So remember, rise, you go up and down. Since it's negative, I'm going to go down 1. And then my run is a positive 4. So I'm going to go to the right 4. 1, 2, 3, 4. And that's where you put your dot. If you had used the other one, 1/-4, to see what you would get. Hopefully they would lie in the same line. From your y-intercept, you go up 1, since my rise is positive 1. Now my run is -4, so that means you go to the left now. 1, 2, 3, 4. So this is where you get your other point. And notice they do lie on the same line. So it did not matter which one you used. Okay, it does not matter. You still get the same line. All right, again, if they say to label it, this was number 5. If they say to label it, this point would be 4, -1. 0, 0 is the origin. And this point is -4, 1. Okay? All right, now, so notice all we did here was talk about slope-intercept form. Y equals mx plus b. Y equals mx plus b. Y equals mx plus b. Okay? Now, what if you just had this? Number 6, y equals 2. Y equals 2. So basically, in these problems, number 6 and let's say number 7, x equal 2. Let's look at that. So y equals 2, x equal 2. Now, remember, slope-intercept form is y equals mx plus b. Okay? Y equals mx plus b. So right here, if you want to try and rewrite this in slope-intercept form, you got to be careful. You would say y equals 0x plus 2. All right, 0x plus 2. Now notice, make sure you understand that this right here is this. Because 0 times x is 0. 0 plus 2 is 2, so you get that back. See this one right here? Y is not there. So there's no way you can write this as slope-intercept form. Okay, you can't because the y is not there. No y. All right. So the best way of doing this is whenever you have y equals or x equal and just a number, the best way of doing that is to use a t-table. So we're going to use a t-table. Okay, now you see how you can write this in slope-intercept form? Here the slope is 0 and the y-intercept is 2. But again, here you can't. There's no way you can write this in slope-intercept form because there's no y variable. Here there's a y variable, so you can write in slope-intercept form. You have to write it like this. Slope is 0, y-intercept is 2. Okay? So it's a little confusing for students, though, when the slope is 0. They don't know what to do with this. So here's what I'm telling you to do. Do a t-table. Remember, this says that y always equals 2. Y is always going to equal what? 2. That's what that says. This says that x is always going to equal what? 2. That's what that says. X is always going to equal 2. So here again, y always equals 2. That's what that says. This says y always equals 2. This says x always equals 2. That's what that says. No matter what, for this one, y always equals 2 no matter what x is. No matter what x is, y always equals 2. Here, x equals 2 no matter what y is. X always equals 2 no matter what y is. So when I graph these lines, I want you to notice something. Y equals 2, x equals 2. Let's do number 6. So y equals 2. So I get the point 0, 2, which is here, and then negative 1, 2, which is here, and then 3, 2, which is here. And I want you to notice something. When I connect those points, what do you notice about that line? Well, you notice that that line is a horizontal line. That's a horizontal line. And remember in the previous lesson, we talked about horizontal lines having slope 0. Remember that? So the horizontal line had slope 0, and that's what this was. The slope was 0. So that's a horizontal line. So whenever you get y equals a number, that's a horizontal line. And it crosses the y-axis at that number that you see. So you see at 2, that's where it crosses the y-axis. For number 7, again, if I label some of these points, if I plot some of these points, I get 2, 0, which is here, 2, negative 1, which is here, and then 2, 2, which is here. And again, what you notice about this line, about x equal 2? That's a vertical line. So x equal 2 is a vertical line. Okay? Now remember, a vertical line has undefined slope. So that's why you couldn't write this in slope-intercept form because the slope was undefined. Here you could write in slope-intercept form because it had 0 slope, but here you could not. So whenever you have y equals mx plus b like this, like 3, like 4, like 5, you're going to graph it using slope and y-intercept. Whenever you have y equals a number or x equal a number, you're going to graph using a t-table because it's going to either be a horizontal line if it's y equals a number, or it's going to be a vertical line if it's x equal a number. Okay, so if it's y equals a number, it's a horizontal line. If it's x equal a number, it's a vertical line. You just don't use slope intercept with this one. Just go ahead and remember that's a horizontal line. You can't use slope intercept with this one. You cannot because the slope is undefined, so you can't even do that. You can't write this in slope intercept form. You cannot write a vertical line in slope intercept form. All right, let's look at number 8. So remember here we're talking about horizontal and vertical lines. Horizontal, vertical lines. So in the other ones, remember the other ones? They were slanted. They either fell or they rose. Remember that? So they either fell or they rose. The slope was either negative or the slope was positive. Here, horizontal line, y equals a number. The slope is horizontal. That's 0 slope. Here, x equal a number. That's a vertical line. That's undefined slope. Okay? All right, let's look at number 8. Suppose you had this. Suppose you had f of x equal negative 3. F of x equal negative 3. Now remember f of x, you gotta remember this, you gotta rewrite this to help you. F of x means the same thing as y. So this means the same thing as y equals negative 3. Well, remember, if it's just y equals a number, what kind of line is this? Is it horizontal? Is it vertical? Well, if you get confused, do the t-table to get confused. So this says that y always equals negative 3. So in the y column, you're going to have negative 3 throughout. And in the x column, you can put whatever you want in the x column. Because it says that y always has equals negative 3 no matter what x is. So when I graph this, I want you to notice what you get. So this is number 8. F of x equals negative 3. So when I plot those points, 0, negative 3 is here, right here. 0, negative 3. Negative 1, negative 3 is here. And notice I get a horizontal line. So remember, y equals a number is a horizontal line. I get this horizontal line. Okay? Now, number 9, suppose you had this. So this is a horizontal line. What if you had 2x minus 6 equals 0? Suppose you had that. 2x minus 6 equals 0, and you want to graph this. Alright, this is a little confusing for people because normally they'll see either y by itself or x by itself. Alright, so see there's no y here, right? So let's just get x by itself, see what happens. So remember, you want to graph this. You want to graph. So if I get x by itself, I'm going to get 2x equals 6. I'm going to add 6 to both sides. Alright, so I get 6. And then divide both sides by 2. I get x to be 3. Alright, x is 3. So let's graph x equals 3. So when x equals 3, remember what kind of line is this? Is this a horizontal line or a vertical line? And if you're not sure, some of you probably said it correctly. It's a vertical line. Some of you probably did not. If you did not, here's what I would do. Since I have x equal a number, just like I did with y equal a number, I'm going to use a t-table. So xy. Now remember, this says that x always equals 3. So in this column x, I have to always use 3. That's what that says, no matter what y is. So now I can just go ahead and plot those points and notice what you're going to get. Remember, graphing 2x minus 6 equals 0. So let's see what you get. You get 3, 0, which is here. That's 3, 0. You get the other point, which is 3, negative 1, which is here. And then notice when I draw a line through those 2 points, I get what kind of line? I get a vertical line. That's what I get, a vertical line. And so this is a vertical line. Now remember, a vertical line has undefined slope. Okay? All right, so one of the other things I want to mention is this. Just kind of reviewing real quick about this. Okay, so remember, slope-intercept form is y equals mx plus b. And in this section, remember, in this section, when you can write in slope-intercept form, remember, you cannot always write in slope-intercept form, just like we saw. So vertical line, you can't write in slope-intercept form, but whenever you can write in slope-intercept form, you want to use the slope and the y-intercept. So remember what we did when graphing using slope and y-intercept. Let me get to it. So what we did first was we plotted the y-intercept. So that's what this says. Plot the point containing the y-intercept on the y-axis. Okay. Then we use the slope, rise over run, to get the other point. So then obtain a second point using the slope. And if it's a whole number, just write as a fraction and use rise over run, starting with the point containing the y-intercept. So remember, we started with y-intercept and we used rise over run. And then use a straight edge to draw the line. Okay, so that part about if it's a whole number or an integer, let me just explain what that means. So let's write this as number 10. Number 10. All right, suppose we had f of x equal negative 4x plus 2. Negative 4x plus 2. All right, so first of all, is this in slope-intercept form? You should have said yes, because that's y equals mx plus b. So what's the slope? Well, the slope is negative 4. That's your slope, negative 4. What's the y-intercept? Well, the y-intercept is positive 2. Now, if that was negative 4x minus 2, you better say the y-intercept's negative 2. So positive 2. So from this will be number 10. So from here is number 10. Okay, so from here, remember the first thing you do is you're gonna plot your y-intercept. Now remember, for some of you, people get confused with this. They don't see it. They don't see the rise over run. But remember, 2 is the same thing as saying 2 over 1. All right, so rise a fraction. That's all this part says. This part says write m as a fraction. All right, so if you don't see the fraction, if it's just an integer, rise a fraction. It'd be 2 over 1. 2 over 1 is 2. So this is all going to be a 1 down here. You should always use a 1 down here. So we're gonna I'm sorry, I meant the slope. Excuse me. Slope again will be negative 4 over 1. Excuse me. So it's the y-intercept is 2. So the y-intercept is 2. So that's here. It says the slope is an integer. Write it as negative 4 over 1. So here's your rise and your run. So your rise is negative 4. The run's positive 1. Okay, so from here, I'm going to go down 4. 1, 2, 3, 4. And my run was a positive 1, so go to the right one. And so there's your other point. And then you just connect them and you're done. All right, so the slope's an integer. Always rise a fraction. Just use 1 in the denominator. And so there's your graph. And that's it. And just notice the line is falling as you go from left to right. Your line's falling. And it better be because the slope was negative. Okay, so that takes care of graphing lines.